Welcome to today's video, guys. Today we are going to discuss about B-tree insertion of order 4. So let's go into our video. In the case of this B-tree insertion, in which the order of the tree is 4, we know that the maximum number of keys possible for this particular tree is order -1. So here 4 minus 1, so 3. In a single node, maximum we can store 3 keys in that particular node. So that is the meaning of this maximum number of keys. And minimum number of keys for a single node is 1. That is m by 2 minus 1. That is 4 by 2 minus 1, so we got it as 1. Here we know that the order is an even number, right? So it's 4, so it's an even number. In the case of this even number, means if the order is even number, we can do the splitting in 2 ways. Basically, if the order is an odd number, it will be very easy for a splitting, because we just need to move the middle key upwards, so that will be easy. But in the case of this order 4, in case of a B tree wherein which the order is an even number, we can do the splitting mainly in 2 ways. Okay, in our case the order is 4, so maximum keys is 3, and here the maximum or the number of key this particular node holds become 4, so we violated our maximum keys condition, so we have to do a splitting here, right? In normal case, suppose that if we have this 8, 9, 10, if we need to do a splitting in this scenario, it will be very easy, right? We just move this, we just have to move this middle element 9 upwards into a separate node, and 8 will become a separate node, and 10 will become a separate node. So that will be very easy. But in this case, in such a case wherein which we have to apply splitting, we can choose 2 different methods: left biased splitting as well as right biased splitting. The concept is just simple. We can move either of this 9 or 10 upwards. Okay. In left bias casing, what we are doing is that we will choose this left element to move upwards, and this left element will be moved upward and it will be stored in a specific node, and this 8 will be split into a different node, and 10 and 11 will be split into different node. So this is left bias splitting. In this same scenario, we can also apply right biased splitting. Moving 9 upward, then it is left biased splitting. If you are moving this 10 upward, then it is right biased splitting. If we are moving 10 upward, 8 and 9 will become a single node, and 11 will be stored in a separate node. So this is right biased splitting. So in the example that I am going to discuss, we will be focusing on this left biased splitting. You can do it in either way, no problem at all. So first of all, let's take an example problem. Here I have considered so many keys. I have to insert these keys into a B tree of order 4. So let's see how we can do this problem in a simple manner. Okay. First of all, the first key that I am going to insert is 8. So I created a node and inserted this 8 into that particular node. After that, I have to insert the key 9. No problem at all. I have inserted this 9 along with this 8. One thing that we have to keep in mind is that in a particular node, the keys will always be in a sorted manner. Okay, so I have to insert it in such a manner that the keys will always be in a sorted manner. So this after 8, I have inserted 9. Then next key to be inserted is 10. Here after 9, I inserted 10 in this specific key itself, because I know that in this particular node, maximum number of keys that I can be inserted is 3. So this is not at all violating my condition. I can proceed with the next key. The next key is 11, and I inserted this 11 after this 10. So now this particular node consists of 4 keys: 8, 9, 10 and 11. So the present key number is 4. But we know that the maximum keys that is possible in a single node is 3. So here my condition is violated. So I have to do a splitting here. Okay. So this particular node how to be splitted. So I perform a splitting. Here I am doing a left biased splitting, wherein which this 9, either I can move 9 or 10 upwards. Here I am choosing this 9 and I move this 9 upwards. After that, how will this node become? 8 will become a single node, and 10 and 11, this case will be stored in a separate node. Okay, so now none of my conditions are violating. I can proceed. So I choose the next key value to be inserted, that is 16. We know that our root node is this 9. Since the inserted element 16 is greater than 9, I am choosing this right child of 9. Why? B tree will always act as a binary search tree. Okay, so in binary search tree, the right element will be greater than the root and the left element will be lesser than the root. So since 16 is greater than 9, I choose this right element and I inserted 16 after 10 and 11. So this is not at all violating my condition, so I can proceed with the next key. I choose the next key 17. Here 17 is greater than the root node 9. So I choose this right child of 9. Here after 10, 11 and 16, after these key I inserted this particular key 17. Now the total number of keys become 4. But the maximum number of keys that is possible is only 3. So since our condition is violated, we have to do a splitting in this particular node. Here also, either I can move this 11 upwards or I can move this 16 upwards. Here I am choosing a left biased splitting, so I move this 11 upwards along with this 9 in this specific node. So this 11 came upwards along with this key 9. We write this node as such, not change at all. Here since 11 is moved upward, we have to split this specific node. So 10 will be stored in a single node and the remaining 16 and 17 will be stored in a separate node. Here when we look into this particular nodes, we know that 8 is lesser than 9, then 10 is greater than 9 as well as less than 11. That is why the arrow is like that. This 10 or this particular node is the right child of 9 since it is greater than 9, and this particular node itself is the left child of 11 since it is less than 11. Okay, since this 16 and 17 greater than 11, it will become the right child of 11. So this is how our node will become after splitting. Then after that, the next key that I have to insert is 1. So this key that I have to be inserted 1 is lesser than the first key 9. So it will move to the left side of or left child of this 9 along with this 8. But since in a specific node the keys have to be in an ordered manner or in an increasing order manner, I inserted this 1 just before this 8. So it will become 1 and 8. So none of my conditions are violated, so we can just proceed with the next key. So next key is chosen to be 20. Since 20 is greater than this 9 and 20 is also greater than the next key 11, 20 will be placed in the right child of 11, that is along with 16 and 17 in this particular node. So I inserted this 20. So since this is not at all violating our condition, here the keys become 3, 1, 2, 2. Maximum key can be up to 3. So this is not violating our condition. So we can go with the next key value, that is 12. So this 12 is greater than 9. 12 is also greater than 11. So 12 will be stored in the right child of the 11. Okay. Also I have to store this 12 in such a manner that in that particular node all the keys will be in a sorted order. So for that I stored this 12 just before 16. So now the keys become 12, 16, 17 and 20. Here the present number of keys is 4, but the maximum number of keys is allowed for a single node is 3. So since this is violating our condition, we have to split this specific node Either 16 or 70 has to move upward along with 9 and 11. Here I move 16 upward. So when I move 16 upward, 12 will be stored in a separate node and 17 and 20 will be stored in a separate node. So 1 and 8 are written as such. This 10 is written as such. 12 become a separate node. 17 and 20 become a separate node. This 60 moves upward. So now 1 and 8 are lesser than 9. 10 is greater than 9 as well as lesser than 11. So that is why here right child of 9 and left child of 11. 12 is greater than 11. So right child of 11. As well as 12 is lesser than 60. So left child of 16. Then 17 and 20 are greater than 16. So it becomes the right child of 16. So this is how we will be performing a B tree insertion in the case of a tree where in which the order is 4. So I hope that this is clear.